So you write some code. How does it actually run? How does your computer bring it to life? Well, it all comes down to this big idea, a kind of battle between two types of translators, the compiler and the interpreter. Let's get into it. At first glance, this seems pretty straightforward. But just stop and think about it for a second. The code you write, it looks a lot like English, right? It's got words, logic, structure. But your computer's brain, the processor, it only speaks one language, and that language is binary, just zeros and ones, on and off. That's it. So bridging that gap, that's the core problem every single programmer has to solve. And how we do it is actually pretty cool. Okay, so let's just take a moment to really appreciate the scale of this translation problem. So look at this. On one side, you've got a line of code that we as humans can read and understand perfectly. Print, hello, world. Simple enough. But on the other side, that's what your computer actually gets. That's the machine code. It's just a raw stream of ones and zeros. The two could not be more different. It's like trying to compare Shakespeare to Morse code. Right, so obviously we can't just throw our human readable code at the computer and cross our fingers. It just won't work. We absolutely need something in the middle, a special program that acts as our translator. And it turns out there are two main ways to go about this, two different philosophies for the job. All right, let's meet our first type of translator. This is the compiler. And if you want to think of it in human terms, it's kind of like the super meticulous, detail-oriented planner of the group. The most important word to remember with the compiler is entire. It doesn't mess around with one line at a time. No, a compiler goes through your entire program from top to bottom and translates the whole thing in one go. The result is a brand new file, a fully translated, machine-readable program. The book analogy is perfect. You translate the whole book first, then you hand it over to be read. So the workflow here is really clear and step-by-step. First, you write your code. Then, step 2, you run the compiler to translate everything. And only after that's done, as a third and final step, can you actually run the program. That middle compile step is totally separate. And what's really cool is that the final output, that executable file, is completely standalone. It doesn't need your original code or even the compiler anymore to do its job. Okay, so there's a really clear trade-off here, right? The biggest pro is speed. I mean, your final program runs fast, like really fast. And that's because all the heavy lifting of translation happened ahead of time. Plus, it's like a proofreader for your whole project. It checks everything at once and finds errors before you even try to run it. But the con? Well, you've got to pay the price up front. That initial compilation step can take time, sometimes a lot of time. And you see this in action with languages like C and C++. These are the classics. Whenever performance is the #1 non-negotiable goal, you're probably looking at a compiled language. We're talking about high-end video games, your computer's operating system, massive scientific simulations. That's where compilers and languages like C++ really, really shine. So if the compiler is that careful planner, what's the other option? Well, let's meet the interpreter. And if the compiler plans everything out, the interpreter is more of an on-the-spot improviser. Yeah, this approach is completely different. It's all about translating on the fly. An interpreter reads one single line of your code, translates it, executes it immediately, and only then does it move on to the next line. The live translator analogy is spot on. It's like someone whispering a translation in your ear, sentence by sentence as a conversation happens. So look at the steps here. You write the code, and then the interpreter just starts running it, line by line. See what's missing? There's no separate compile step. There's no new executable file being created. For an interpreted program to run, you need both the interpreter and your original code right there together. It's this constant loop. Read a line, translate it, run it, repeat. The upside here is huge, and it's all about immediacy. You hit run, and your code just starts instantly. This is amazing when you're developing because you can make a tiny change and test it right away. But, of course, there's a downside. All that on-the-fly translation work means the program as a whole is generally slower. And here's the kicker. An error could be hiding on line 500 of your code, and you won't know about it until the program actually gets to line 500, which could be a surprise. And you see this model everywhere. I mean, think about some of the most popular languages out there today: Python, JavaScript, PHP. These are giants, especially in things like web development or data science. And a big reason they're so popular is because they're easy to get started with and you can develop things really quickly. That's a direct result of using an interpreter. Okay, so we've met the planner and the improviser. Let's put them head to head and really nail down the differences. This table really lays it all out. You've got the compiler, which translates everything at once, giving you a faster final program and checking for all your errors before you run. but you have to wait. On the other hand, you have the interpreter, translating line by line. It's way more flexible and starts instantly, but it's slower overall and finds errors as it goes. It really boils down to that one simple question. Do you need your speed during development, or do you need your speed when the final program is running? But what if it's not a strict choice? What if you could have your cake and eat it too? In the world of programming, people are always trying to get the best of both worlds, and some modern languages have found some really interesting ways to do just that. Yeah, this is where things get super clever. The thinking is, why stick to just one approach? Let's try to combine them. So these hybrid models have popped up, and the whole goal is to get some of that raw speed you get from a compiler, but keep the flexibility and portability of an interpreter. And the poster child for this approach is Java. Here's how it works. First, you take your Java code and you compile it. But, and this is the key part, you don't compile it all the way down to machine code, you compile it to this intermediate thing called bytecode. Then you take that bytecode and hand it over to an interpreter, which in Java's world is the famous Java Virtual Machine, or JVM. The JVM then runs that bytecode. So see, you get some of the benefits of compiling up front, like error checking, but you also get the write once, run anywhere portability that interpreters are so good at. Okay, so why do we care? As a programmer, why does any of this under-the-hood stuff actually matter to you? Look, if there is only one thing you take away from all this, make it this quote. A compiler is like translating a whole book before you read it. An interpreter translates it for you, sentence by sentence as you go. That one analogy really locks in the entire concept. One is all about preparation, the other is all about being live and in the moment. And that's really the bottom line, isn't it? Knowing how your code runs isn't just some fun fact for trivia night. It's a genuine superpower. It's what helps you pick the right tool for the job. It's what helps you figure out why your program is crashing or why an error only shows up sometimes. Ultimately, it just makes you a better, more effective programmer. So I'll leave you with this question to think about. As you go about your day, look at the apps you use. That fast-paced, graphics-heavy game on your phone, was that probably compiled for every last drop of speed? And what about the interactive website you're scrolling through? Is that likely being interpreted for maximum flexibility? Once you start asking the question, you'll start seeing the signs everywhere.